generate a relation between the mobile robot with the absolute frame. Okay, so suppose we have this is okay, so this is absolute frame, and this is absolute x-axis, and this is absolute y-axis, and this is absolute z-axis. So here z-axis is coming out of the paper. Okay, that is why this is okay like that. This is ZA. And we also have discussed that the degree of freedom for the differential drive mobile robot is what? 3. Okay, so suppose this is the differential drive mobile robot. Okay, so in this, so this is the differential drive mobile robot. So it has two drive. So this is left wheel, this is another, so two independent drive. Okay, so here is one motor, here is another motor, and both are independent. Okay, and the motion of this robot happened due to this both wheel. Okay, so suppose omega r is the angular velocity of this wheel, and r is the radius. Okay, r is the radius of this wheel. Okay, and this, suppose this w is the, or let's take it b, this width or separation between this wheel is suppose d. Okay, and angular velocity of this wheel is what? Suppose wl. Okay, and linear velocity is suppose vl, and this is vr, and this is overall velocity of the robot, that is v. Okay, this robot has two sensors, basically two sensors required for this robot. Okay, first is heading sensor. So from heading sensor we come to know how much angle this robot has turned with respect to this absolute axis. So directional information about this mobile robot, okay, we got we get with the help of this heading sensor. Okay, and other is encoder. Generally incremental type encoder is used in this differential drive or mobile robot. So here, using this encoder, we know the information about this turning velocity, okay, of the wheels. Okay, and all the information are sent to the absolute frame. That is why we need to generate a relation, a mathematical relation between this robot with the absolute frame. Okay, so that from standing at the absolute frame, we come to know how, where is the position, how, what is the angle, what is the every detail of this robot we come to know when we generate a relation between this robot with the absolute frame. Okay, so for that we need to know some basic equations. Okay, so some basic equations are what? So we need to know this linear velocity v equal to what? V equal to angular velocity. Okay, so linear velocity of suppose L, left wheel, angular velocity of left wheel, and radius. Okay, radius of this left wheel. Okay, and VR will be what? How this linear velocity is related with the angular velocity. Okay, so VR is omega r into r. R is what? Here r, small r is radius of this wheel. Okay, and other relation, suppose this robot is turning, okay, about a instantaneous center of rotation, ICR. Okay, and it is making and a radius, a turning radius, that is RC. Okay, turning radius. So V will be what? V will be this suppose this theta dot, it is turning by theta. Okay, so theta dot will be what? Turning velocity. Okay, so turning velocity into RC. Okay, these are some basic relation. Okay, and other relation is very important relation is what? P, this overall velocity of this robot, and what is the relation between this right velocity of right wheel and left wheel is what? VL plus VR by 2. Okay, velocity of this robot with respect to absolute x will be what? V cos theta. Okay, again we can write v is what? V is VL plus VR by 2. Okay, now we are talking about x-axis, velocity about x-axis, so we will take the only x component of the left wheel and right wheel. So VL x, VR x. Okay, cos theta. Okay, again we can write here, so from here we can write omega L R by 2 cos theta, okay, plus omega R okay, by 2 cos theta. Okay, so just from here we are putting this value over this and okay, doing a little bit mathematical operations, so we are getting this. Similarly, we can also get Vy equal to V sin theta or V Ly plus V Ry by 2 sin theta or omega L R by 2 sin theta plus omega L R by 2 sin theta. Okay, so we got the relation between this the the rotational speed or the speed of the right wheel and left wheel with the speed of the absolute with respect to absolute frame. Okay, and finally we have, so we had 3 degree of freedom. So we got 2 degree of freedom. First degree of freedom is this, second degree of this, third is what? Rotation about z. Okay, so rotation about z is nothing but turning. Okay, this turning velocity of this robot. Okay, so turning velocity is what? From here we have v by rc. We can write, again we can also write v L by rc plus b by 2 we can write. Okay, so this is b and b by 2. Okay, so VL, this is VL, so up to here rc, we have up to here rc and b by 2 this. Okay, so that is it. And for b, VR will be what? We can this rc minus b by 2. Okay, up to here clear. Again, if we will do a mathematical operation, we can also write VL minus VR by RC plus B by 2 minus RC plus B by 2. Okay, we have VL minus VR by B. Okay, so in this way we got the relation, okay, between again we can also write here omega L R, okay, minus omega R by B. Okay, now we will write this equation into, we will convert this equation into a matrix form. Okay, a matrix equation. So finally we got the normal equation. Now we will convert this normal equation into a matrix equation, okay, in the form of matrix. Okay, so why? Because whenever whatever we will, in last class also we have seen, we are to convert everything. Okay, in upcoming classes also we will write the kinematic equation for various robots. At that time also, finally at the end, after doing all operations, we need to convert that equation into matrix equation. Okay, because while writing coding, okay, we write all this equation in form of matrix. Okay, so we have Ex, we have E y, we have theta dot. Okay, if you write this equation, so what will be that? That will be r by 2 cos theta, r by 2 cos theta omega L omega r by 2 sin theta, r by 2 sin theta. Okay, and from here we have r by b minus r by b. Okay, so finally we have this equation. Okay, So after doing this much mathematical operation, finally we will get a matrix, okay, in this form. Okay, so just by while coding a or differential drive robot, we will just convert, okay, after solving all these equations, we will convert this equation into matrix form, okay, and we will just write this matrix in a programming, and after then everything we will get, okay. So we will get with the help of heading sensor we will get the theta, and with the help of encoder we will get the velocity of left wheel and velocity of right wheel. And when we will come to know this, we automatically come to know the velocity about absolute x-axis